The calm before the end, the world was alive with sound. Forests of towering conifers stretched across continents, their roots sinking deep into soils rich with life. Flowering plants, new arrivals in Earth's story, painted the Cretaceous landscape with delicate color. Rivers curled like silver veins through fertile valleys. In the seas, schools of ammonites drifted in spirals of perfect geometry, while mosasaurs ruled the deep like ancient leviathans. Above, the skies were filled with wings, the great pterosaurs, shadows that stretched across the canopy, and the feathered ancestors of birds tracing arcs through the air. On land, giants reigned. Triceratops moved in herds, their horns glinting. Beneath the sun, ankylosaurs lumbered through the underbrush, armored like living fortresses, and towering above them all were the tyrants, predators, whose very footsteps shook the ground. Life, in all its forms, had reached a peak of diversity and grandeur. For over 150 million years, the dinosaurs had dominated Earth, carving their presence into every corner of the planet. The air was warm, humid, heavy with the scent of vegetation. Insects buzzed between ferns as dragonflies hovered like jewels, suspended in light. It was an age of abundance, an age that seemed unshakable, eternal, as though nothing could challenge such dominion. But beneath this flourishing world lay a silence, one that only the cosmos could hear. For fate had already chosen its moment. A visitor from the void far beyond the blue sky, past the moon's quiet orbit, in the cold expanse where sunlight weakens, a wanderer moved. An asteroid, a fragment of stone left over from the birth of the solar system, traced its lonely path through space. For millions of years it had circled the sun, nameless, unnoticed, silent. Neither alive nor dead, it was a relic of creation, drifting between worlds as though waiting for its purpose, drawn by the mathematics of gravity. Nudged by the subtle hands of celestial mechanics, its orbit began to change. Its trajectory bent, curving inward toward the inner planets. Toward Earth, it carried no malice, no awareness of the catastrophe its arrival would unleash. It was simply a mass of rock and metal, 6 miles across, but with the weight of destiny behind it. Yet, to the life below, it would become something more, a cosmic executioner, a messenger of chaos as it crossed the void. Its surface bore scars from countless collisions, each crater a memory of ancient battles fought in silence. And now, it raced toward one final impact, one that would etch itself forever into the story of life. The planet awaited, unaware. Oceans glittered beneath the sun, continents basked in warmth, forests whispered in the breeze. No creature looked to the heavens with suspicion, no instinct warned of what was coming. The asteroid's approach was hidden by distance, cloaked in the vastness of space. But already the clock was counting down. The final sunrise morning arrived as it always had. The Cretaceous dawn spilled gold across the horizon. Mist curled above rivers, dew gathered on fern leaves, and the cries of distant herds echoed through the trees. Dinosaurs stirred, feeding, hunting, moving through landscapes they believed eternal. Nothing in the air betrayed the truth. The skies were calm, the earth steady beneath their feet. Life continued its endless rhythm. Unaware, it was playing the final notes of a song millions of years in the making. Above them, far beyond sight, the asteroid pierced the atmosphere at tens of thousands of miles per hour. The sky itself began to tear, molecules igniting in incandescent fury as the stone descended. In seconds, day would turn to fire. In moments, kingdoms would vanish. Does life ever sense the end before it comes? Do creatures stir at the edge of catastrophe, touched by some instinct that cannot be named? Or does existence carry on in ignorance, blind to the abyss opening before it? In that final morning, the dinosaurs grazed and hunted, the ammonites drifted in the seas, the pterosaurs soared. All was as it had been for ages, yet history had chosen this day, this hour, this moment. The calm would not last. The visitor had arrived. Paleontological puzzles for centuries, the stone layers of Earth have been treated as a library, a record of worlds that no longer exist. Each stratum holds the remnants of vanished oceans, ancient forests, and the bones of creatures long forgotten. Two early fossil hunters of the 18th and 19th centuries. These layers whispered of a truth too vast to comprehend, that Earth had once been populated by forms of life, completely unlike those that walked it now. The discovery of fossilized giants, ichthyosaurs in England's cliffs, the first dinosaur bones unearthed in the Midlands, and strange marine shells found on mountaintops, unsettled naturalists. They revealed a disturbing pattern. Species did not simply change slowly, as Darwin later suggested, but seemed, at times, to vanish abruptly from the record. By the mid-19th century, paleontology had become a science of loss. The geologist Georges Cuvier, studying the strata near Paris, argued that Earth's past was marked by violent upheavals, catastrophes that swept away entire faunas in a single stroke. Others resisted this view, believing instead in uniformity and gradual change. Charles Darwin himself was deeply unsettled by the sudden breaks in the fossil record. On the Origin of Species, he speculated that the gaps were illusions, the result of an incomplete archive. Evolution, he believed, moved slowly and imperceptibly, not through apocalyptic ruptures, but the rocks held their silence. Across the globe, paleontologists continued to note the same puzzle. At the boundary between two geological ages, entire lineages disappeared. The ammonites, those coiled masters of the sea, the great marine reptiles, the dinosaurs themselves, all gone at once, as if history had turned a page in fire. It was a mystery suspended in stone, waiting for a voice to interpret it. The Alvarez hypothesis, that voice, came not from a paleontologist, but from a physicist. In the 1970s, at the University of California, Berkeley, Nobel Prize-winning physicist Luis Alvarez worked with his son, geologist Walter Alvarez. Their interest was not extinction, but time itself, the precise measurement of how long geological events had taken. While studying a thin band of clay in Gubbio, Italy, Walter Alvarez faced a question. This layer of reddish clay marked the transition between the Cretaceous and the Paleogene, the very moment when the dinosaurs vanished. Why was this layer so unusually thin, representing what seemed like a long silence in the geologic record? To answer, father and son turned to chemistry. With colleagues Frank Asaro and Helen Michel, they measured the clay's composition with unprecedented precision. What they found startled them. The clay contained an element almost absent from Earth's crust, iridium. Iridium is exceedingly rare on the surface of this planet. Yet it is common in meteorites and asteroids, the rocky debris that still drifts through the solar system. The concentration they measured was not a trace, but a spike, a level hundreds of times greater than normal. The Alvarezes asked a question few others dared. Could the disappearance of the dinosaurs have been caused by an impact from space? They calculated the numbers. To spread this much iridium across the globe, the object would need to have been several kilometers wide. Its impact would have released energy equivalent to billions of nuclear bombs, igniting global fires, throwing debris into the sky, and blocking sunlight for months or years. In 1980, they published their revolutionary paper. It did not speak of gradual decline, nor of slow evolutionary drift. It spoke of a single day, a single moment when chance collided with life and nearly ended it. Their proposal was met with disbelief. Could so mighty a dynasty as the Dinosaurs, rulers of Earth for 150 million years, really have been ended by one stone falling from the void? Yet the clay spoke, and the world began to listen. Clues around the globe, the Alvarezes had uncovered one anomaly, but science demands repetition, confirmation, and a search for patterns beyond coincidence. So geologists and paleontologists scoured the earth, seeking the same signal. They found it in Denmark, in layers of ancient seafloor. They found it in New Zealand, at the edges of long-lost oceans. In North America, they uncovered the same thin band of clay, rich in iridium, dividing two worlds, the age of reptiles below, the age of mammals above. The pattern was undeniable. Across continents, separated by thousands of miles, the same chemical fingerprint appeared, a global scar, as if the entire planet had been brushed with dust from the stars. Other clues began to emerge. Grains of quartz found in the boundary layers bore microscopic fractures, shock features that only appear under pressures greater than those generated by nuclear weapons. Tiny glass spherules, droplets of molten rock cooled in the air, appeared in sediments worldwide, as though the sky itself had once rained liquid stone. Taken together, these were not random curiosities. They were evidence of a singular event, one so immense that it reshaped the biosphere. A mystery that had lingered for over a century was converging on an answer. The abrupt disappearances in the fossil record were not illusions nor failures of preservation. They were the signature of catastrophe written in ash and fire. But the revelation carried with it something even more unsettling. If one stone from the heavens could erase 3/4 of all species, what did that mean for the stability of life itself? What did it mean for Earth's place in a universe where destruction could fall unannounced from the dark? The detective story was only beginning. For even as the evidence of impact grew undeniable, one question remained. Where was the wound? Where on earth lay the crater that bore the mark of the deadliest day in history? The resistant science advances through conflict, not only with nature's mysteries, but within the minds of those who seek to explain them. When the Alvarez hypothesis was unveiled in 1980, it did not land on a blank slate. It collided with a century of established belief. For decades, geology had been guided by a philosophy of patience. The Earth, it was thought, was shaped not by sudden convulsions, but by slow, relentless processes, the steady rise of mountains, the gentle accumulation of sediments, the long erosion of rivers carving stone. This principle, known as uniformitarianism, had been championed since the time of Charles Lyell in the 19th century. It became a shield against the old myths of floods and divine Seater, Kelmius ms. To suggest that a single day had rewritten Earth's biological story was to challenge this creed. At its core, extinction, according to the reigning view, was a gradual fading. Dinosaurs, many paleontologists believed, had dwindled over millions of years, their numbers falling long before the final disappearance. Perhaps they had been weakened by changes in climate or by competition with mammals. Some imagined they had simply grown too specialized, too inflexible to adapt against this backdrop. The idea of a sudden, apocalyptic ending seemed almost unscientific. To many, it sounded like a return to the catastrophic visions science had worked so hard to escape. The resistance was fierce. Conferences in the 1980s echoed with debate. Some accused the Alvarezes of oversimplifying, of chasing a sensational explanation. Others argued that the fossil record showed too many complexities to be explained by a single strike. Could an asteroid alone account for every disappearance, on land and in sea? Could one impact silence forests, oceans, skies, and rivers alike? In the quiet halls of universities, in journals and lecture rooms, the shock of the hypothesis rippled like a tremor. The Earth, once thought stable, was being recast as vulnerable, fragile, exposed to forces from beyond, a cosmic killer to accept. The asteroid hypothesis required more than evidence. It required a reorientation of perspective, for if one stone from the void could shatter an age, then Earth was not sovereign in its destiny. It was prey to the cosmos. The idea felt almost implausible. In a universe so vast, could such a direct collision truly have occurred? The solar system was ancient, 4.5 billion years of orbital dance. To imagine a 6-mile-wide rock striking Earth precisely at the end of the Cretaceous seemed too many. Like an improbable coincidence, paleontologists raised their doubts. They pointed to long-term declines in dinosaur diversity suggested by certain fossil beds. In North America, some argued, species counts had already been falling for millions of years. Perhaps the asteroid was merely the final blow to a dynasty. Already weakened, others turned their gaze toward the Earth itself. In India, vast fields of basalt stretched across hundreds of thousands of square kilometers, the Deccan Traps. These colossal volcanic eruptions, pouring out lava and gases around the same time as the extinction, seemed to offer a rival culprit. The scale was almost incomprehensible. Millions of cubic kilometers of molten rock spreading over land, releasing carbon dioxide and sulfur into the skies. Could such outpourings have poisoned the atmosphere, warmed the climate, and destabilized ecosystems? Evolutionary theories also lingered. Perhaps dinosaurs, some said, were doomed not by cosmic accidents or volcanic fire, but by their own biology. Large, slow-breeding, inflexible, they may have been outcompeted by mammals, whose smaller size and adaptability offered resilience. The asteroid, in this light, became a question mark rather than an answer. Was it the executioner, or only one conspirator among many? The turning tide jet evidence, like pressure building in stone, began to accumulate. Each new discovery added weight to the unthinkable. The iridium layer, at first a curiosity, was confirmed in site after site on every continent. Shocked quartz grains appeared across the globe, crystals deformed in patterns that only colossal impacts could produce. Tiny glass spherules, droplets of vaporized rock, were found in sediments spanning oceans. These were not regional accidents. They were global fingerprints by the early 1990s. Seismic surveys revealed the buried outline of a massive crater beneath the Yucatan Peninsula, Chicxulub, nearly 200 kilometers wide. It matched the scale required by the Alvarez calculations. Its age, too, aligned with chilling precision, minus 66 million years. The resistance began to fracture. Skeptics who had once dismissed the idea now faced evidence carved into the Earth itself. The gradualist vision of a quiet, declining could no longer stand unchallenged. Philosophically, the shift was profound. Science had long sought to banish catastrophe from its vocabulary, to replace myth with slow process. Yet here was catastrophe returning, not as myth, but as measurable truth. Earth was not a sealed stage upon which life unfolded in isolation. It was part of a wider system, a celestial body subject to the mechanics of a chaotic cosmos. The asteroid did not only kill the dinosaurs, it shattered the illusion of safety. It reminded science and humanity that the sky above is not empty, but filled with wanderers, fragments of rock and ice whose paths may one day cross our own. The turning tide of acceptance carried with it unease. If one such impact could erase 75% of all species, what prevents it from happening again? The fossil record offered no reassurance. It spoke only of vulnerability, of a fragile biosphere balanced on the edge of cosmic chance. Reflections. In shock, the acceptance of the impact hypothesis was not a triumph of discovery alone, but of humility. It forced science to recognize that Earth's story cannot be written in isolation, nor dictated by slow, predictable rhythms. Catastrophe, rare though it may be, is part of the fabric of existence. The shock was twofold. First, that life, resilient, adaptive, expansive, could be undone in a single day. Second, that the universe, vast and indifferent, is capable of delivering such blows without warning. To look at the Chicxulub impact is to confront a paradox. It was both an ending and a beginning. Annihilation for the dinosaurs, but opportunity for mammals. The fall of one dynasty, the rise of another. Out of death came possibility, and eventually, humanity itself. But in the scientific community of the 1980s, this reflection was still in its infancy. The debates raged on, the resistance lingered, yet beneath it all, the truth pressed upward. Like buried magma, unstoppable, undeniable. The Earth had been struck. Catastrophe was real, and the story of life would never again be told without it. The hunt for the crater evidence had mounted. The iridium, the shocked quartz, the spherules of glass, all pointed toward catastrophe. Yet there remained one crucial piece missing: the scar itself. For if a cosmic hammer had struck the Earth with such violence, where was the wound? Throughout the 1980s and early 1990s, scientists scoured the globe for a crater large enough and young enough to account for the extinction of the dinosaurs. The task was daunting. Over tens of millions of years, Earth reshapes itself. Erosion wears down mountains. Oceans rise and fall. Forests and deserts expand, conceal, and erase. A crater born in fire 66 million years ago could easily lie hidden, buried beneath layers of younger rock or swallowed by the sea. Many candidates were proposed. In the United States, geologists considered the Manson crater in Iowa, but its age did not match. In Ukraine, the Baltish crater sparked discussion, yet it too fell short of the necessary scale. Dozens of sites were examined, compared, and discarded. The search became a puzzle that stretched across continents, leaving frustration in its wake. The answer, as it often does, came from an unexpected direction. Oil companies exploring the Yucatan Peninsula in Mexico had long noticed something strange beneath the limestone. Seismic surveys designed to map potential petroleum deposits revealed a circular structure, nearly invisible at the surface, but unmistakable underground. For years, it was dismissed as volcanic in origin, a curiosity of no greater importance. Yet to a growing number of geologists, its dimensions suggested something else. At last, the pieces began to converge. The buried structure beneath the Yucatan was vast. Its diameter stretched nearly 180 kilometers, larger than the distance from New York to Philadelphia, a scar the size of small nations. Its age, calculated from drilled cores and radioactive dating, fell precisely at the boundary between the Cretaceous and Paleogene. The wound had been found. Chicxulub revealed the name of the nearest village would come to define the catastrophe. Chicxulub, meaning tail of the devil in the Mayan language. Here, beneath layers of younger rock, lay the silent testimony of the deadliest day in Earth's history. Seismic imaging drew a picture of unimaginable violence. The crater's rim rose and fell in vast concentric rings, a pattern mirrored in the great impact basins of the moon. Unlike volcanic calderas, whose structures collapse inward, Chicxulub's geometry was consistent with a single, devastating strike. Drilling projects pulled from the depths fragments of rock melted and reshaped by heat beyond comprehension. Quartz grains, once crystalline and ordered, bore scars of shock pressures far exceeding anything produced by earthly forces. Microscopic spheres of glass, tektites, were found in abundance. Their forms born of rock, vaporized and thrown into the atmosphere before condensing again as droplets raining from the sky. These were not local oddities. The Chicxulub impact had blasted material halfway around the planet. Traces of the same spherules appear in layers of clay in North America, Europe, Asia, even New Zealand. Like fingerprints smeared across the globe, they tied every clue to a single point of origin. Computer simulations reconstructed the event. An asteroid 6 miles wide, traveling at more than 20 kilometers per second, struck Earth with a force equivalent to over 100 million megatons of TNT in less than a heartbeat. The crust rebounded like liquid, mountains rose and collapsed. In minutes, a transient cavity nearly 20 miles deep opened before collapsing into the complex crater now buried beneath. Yucatan's soil. The sheer scale of the blast was beyond imagination. It was not a local disaster. It was a planetary one. Fingerprints of catastrophe at Chicxulub alone was not enough. Science demands corroboration, evidence traced outward like ripples on a pond. And so investigators searched the globe for signs of what the impact had done on the coasts of Texas and across the Caribbean. Geologists uncovered thick deposits of sandstone and broken marine sediments, chaotically mixed and jumbled. These were not laid down by ordinary tides, but by walls of water hundreds of meters high. Megatsunamis, born of the asteroid's plunge into shallow seas, had raced outward, drowning coastlines and reshaping landscapes thousands of kilometers away. Elsewhere, in layers of clay dated precisely to the extinction boundary, soot appeared. Vast quantities of it, black and fine, a chemical fingerprint of global firestorms. Forests, ignited by re-entering debris and superheated winds, had burned on nearly every continent. Charcoal fragments, mixed with iridium dust, spoke of a planet ablaze. The rocks told of skies gone dark, sulfates released from vaporized gypsum. In the Yucatan reacted in the atmosphere, forming aerosols that blocked the sun. The global temperature plummeted. Photosynthesis faltered. Food chains collapsed. In the oceans, microscopic plankton died en masse. Their sudden absence echoed upward into the higher levels of the marine ecosystem. Ammonites, which had thrived for 300 million years, vanished forever. Each fingerprint deepened the narrative. The crater was the origin, but the devastation rippled outward in layer upon layer of destruction. Shockwaves, tsunamis, wildfires, climate collapse. Every clue traced back to the same day, the same hour, the same strike. It was no longer theory. It was forensics. The unveiled scars, the evidence coalesced. Chicxulub was no longer just a geological feature. It became a monument to fragility. The buried scar reminded science that Earth's surface, so seemingly stable, can be rewritten in a single instant. To stand on the limestone plains of the Yucatan today is to see no trace of the catastrophe. The crater is hidden, erased by time, and covered by vegetation. Its presence betrayed only two instruments and core samples. Tourists walk beaches where waves once rose like mountains, unaware of the abyss beneath their feet. Children play in towns that sit atop the rings of the world's most infamous impact. Yet, in the silence of buried stone, the memory remains. Chicxulub is both grave and witness, the resting place of a vanished age and the eternal marker of the day when the dinosaurs' world was undone. The deeper investigation had uncovered the truth. What had once been suspicion was now conviction. The iridium, the shocked quartz, the global soot, the shattered coastlines, all were threads woven into one tapestry. They spoke not of gradual decline, not of slow fading, but of a moment when Earth collided with chance and everything changed. The crater was found. The fingerprints were matched. The verdict was catastrophe. The moment of impacts 6 million years ago, in the final days of the Cretaceous, the Earth turned beneath a tranquil sky. Oceans shimmered in the heat of a subtropical sun. Dinosaurs grazed in fern-filled valleys. In the shallows of the Gulf of Mexico, corals built reefs beneath the waves. And then, without warning, the heavens delivered a blow from the void beyond Mars. A fragment of primordial rock, 6 miles wide, older than Earth itself, struck at more than 20 kilometers per second. It plunged into the shallow seas near what is now the Yucatan Peninsula, carving through atmosphere and water in less than a breath. The energy it unleashed surpassed comprehension. In a fraction of a second, kinetic force converted into fire and shock. The detonation equaled more than 100 million megatons of TNT, billions of times the destructive power of Hiroshima. For comparison, if every nuclear weapon humanity has ever built were detonated at once, the blast would still pale in comparison. The seafloor opened, molten rock rising and collapsing in waves. Crust rebounded like liquid. A transient cavity, 20 miles deep, gaped open before its edges slumped inward, raising concentric rings of mountains in minutes. A plume of vaporized stone and ocean water shot into space, trailing glassy droplets that rained back to Earth. The dinosaurs did not see it coming. There was no time for flight, no time for defense. The planet itself recoiled, global chain reaction from the epicenter. Destruction radiated outward at the speed of sound. The initial shockwave ripped through the atmosphere, flattening forests. Within a radius of nearly 1,500 kilometers, trees splintered like matchsticks. Animals were hurled to the ground by winds that reached thousands of kilometers per hour. Nothing within sight of the blast survived. Across the Gulf, tsunamis unfurled, walls of water hundreds of meters high. They raced outward, battering coasts from the Caribbean to North America. Sediment deposits in Texas, Louisiana, and even as far as Illinois bear the chaotic signatures of these waves. Colossal tides born not of storms, but of planetary convulsion. The skies rained fire. As molten droplets re-entered the atmosphere, friction heated them until they glowed. The heavens turned incandescent. Billions of glassy beads, called tektites, streaked across the world, igniting forests on contact. The Earth became a furnace. Global firestorms, driven by superheated winds, set half the planet ablaze. Charcoal found in Cretaceous sediments is testimony to these infernos, forests that vanished in hours, continents lit by flame. For those who survived the blast, there was no refuge. The destruction had only begun. The impact winter in the days that followed. The planet changed in ways more lethal than the initial blow. The asteroid had struck a region rich in gypsum, a rock laden with sulfur compounds. Vaporized in an instant, it spewed aerosols into the upper atmosphere. Dust and ash joined this sulfur veil, shrouding Earth beneath a cloak that blotted out the sun. Darkness fell. Photosynthesis, the engine of life, faltered. Plants withered. Plankton in the oceans, deprived of light, collapsed in number. Within weeks, food webs began to unravel. The lush ecosystems of the Cretaceous, which had thrived for millions of years, starved beneath a dim sky. Temperatures plummeted. Estimates suggest a global cooling of up to 15 degrees Celsius. Seasonal patterns broke down, leaving deserts to freeze and temperate forests to wither. For years, Earth remained locked in this artificial winter. The oceans, too, bore scars. Sulfur oxides mingled with water vapor to form acid rain, corroding leaves and leaching into rivers. In the seas, dissolved carbon dioxide spiked, lowering pH and acidifying waters. Planktonic foraminiferous, once the architects of marine ecosystems, dwindled and vanished. Coral reefs collapsed. Ammonites, which had survived previous extinctions, finally succumbed. The asteroid had not only scarred the surface, it had poisoned the very cycles that sustain life. The death toll, the tally of extinction, was catastrophic. Within less than a century, the blink of an eye, in geological time, 3 out of every 4 species on Earth were gone. On land, the great dinosaurs perished. Tyrannosaurs, hadrosaurs, ceratopsians, sauropods, all vanished. Only their avian descendants survived, fragile lineages of small feathered creatures that took shelter in the shadows. The age of giants was over in the skies. Pterosaurs disappeared, leaving the heavens to birds. In the seas, ammonites, those coiled marvels that had thrived for hundreds of millions of years, were erased. Mosasaurs, the apex predators of ancient oceans, succumbed to starvation as prey collapsed beneath them. Even plants bore scars. Whole forests vanished, replaced by ferns that spread across the wounded earth like bandages, colonizing the ash-strewn soil. For years, the so-called fern spike dominated pollen records, a silent marker of ecological reset. The world had been rich with diversity, a planet teeming with forms of life that had endured for ages. And yet, in the aftermath of one cosmic collision, 75% of that tapestry was gone. The extinction was not only biological, it was planetary, evolutionary, existential. An entire age had ended in the space of a geological heartbeat. A planet transformed. The catastrophe did not erase life entirely. Pockets of survival persisted. Small mammals, burrowing creatures, birds, fish, and plants resilient enough to endure the collapse. These survivors would inherit a quieter, emptier world. But the transition was profound. The dinosaurs, rulers of the Earth for more than 160 million years, had vanished. The balance of ecosystems was overturned. Mammals, once relegated to the shadows, now found space to expand. In time, they would diversify, filling niches left vacant by extinction. In the distant future, their lineage would give rise to primates, and eventually to humans. The asteroid was not simply a destroyer, it was a shaper, a sculptor of history, a reminder that endings and beginnings are woven together, that death and creation are bound by the same cosmic thread. Chicxulub's strike was a singular moment when the course of life was redirected forever. Without it, the Earth would not be the same. Humanity itself may never have emerged. Reflection in silence today, the impact winter has long lifted. Forests grow once more across the Yucatan. Coral reefs thrive in its shallow waters. Life has healed, adapted, flourished anew. But beneath the ground, the crater endures a buried reminder of fragility. The Chicxulub impact is more than paleontology. It is a meditation on chance. For, in a universe governed by gravity and time, the orbits of asteroids are silent dice, rolled endlessly against the backdrop of eternity. On that day, Earth lost the gamble, and yet, from that loss, a new story began. The end of the Cretaceous was the beginning of another chapter, one that would lead, across millions of years, to the consciousness that now looks back and contemplates the meaning of that single, fateful day. The deadliest day in Earth's history was also, in a paradox both cruel and beautiful, the day that made us possible. Volcanism versus impact. For decades, the Chicxulub crater seemed to close the case. A single asteroid, one strike, one day, one ending. Yet science is rarely so simple. Beneath the rocks of Western India lies another suspect, one that also carries the weight of catastrophe. The Deccan traps here. More than 500,000 cubic kilometers of basalt erupted in pulses over hundreds of thousands of years. Lava flooded the land in waves, building a province larger than Western Europe. Ash choked the skies. Carbon dioxide and sulfur dioxide seeped into the air, shifting global climates. The timing is uncanny. Radiometric dating places the most intense eruptions within a window overlapping the extinction. Could the Deccan traps have weakened ecosystems, destabilizing life before the asteroid delivered its fatal blow? Some scientists argue yes. Volcanic gases would have warmed the climate, acidified the oceans, and stressed food chains already balancing on a knife's edge. In this view, Chicxulub was not an isolated catastrophe but the final strike on a planet already in crisis. Others counter that the scale of the impact winter far exceeded volcanic disruption, that the asteroid alone was sufficient. The debate continues, a reminder that Earth's history is written not in absolutes but in overlapping forces, layered like the rocks themselves. The double blow hypothesis. Perhaps it was not one or the other. Perhaps it was both. The double blow hypothesis suggests that Earth was assaulted from above and below, a world already trembling with volcanic fire met with an asteroid from the heavens. The synergy is haunting to consider. The Deccan eruptions had already released greenhouse gases, warming the planet. Chicxulub's impact, in contrast, drove it into sudden cold. A climate in whiplash, oscillating between extremes, would have pushed ecosystems beyond survival. Some models suggest that the very impact which killed the dinosaurs may have triggered the most violent pulse of Deccan volcanism, releasing even more gases into the atmosphere. In this vision, asteroid and volcano were not separate actors, but accomplices in a single extinction. Whether coincidence or connection, the overlap deepens the mystery. Earth, it seems, can be undone by multiple hands at once. Alternative speculations, though the asteroid has become the accepted culprit. Other ideas linger, whispers of additional wounds, that may have bled the planet. Acid rain, formed from sulfur and nitrogen compounds, may have stripped forests of their leaves, sterilized soils, and poisoned fresh water. Methane release from destabilized seafloor hydrates could have tipped the climate into chaos, magnifying warming after the cold of the impact winter. Ocean anoxia, the depletion of oxygen, may have suffocated marine life already struggling. In acidic seas, each hypothesis paints a picture of cascading collapse. The end of the Cretaceous may not have been a single strike, but a convergence of disasters, impact, volcanism, chemical poisoning, and climatic whiplash. Together they formed a storm so complete, so relentless, that survival became almost impossible, and yet not impossible. Chance and survival, for amid the destruction, life endured. Small mammals, fragile birds, and the ancestors of crocodiles passed through the gauntlet of extinction and emerged into the Paleogene. Why? Size may have been part of the answer. Smaller creatures required less food, could hide in burrows, and reproduce more quickly. Mammals sheltered underground or beneath vegetation, protected from the fires above. Birds descended from theropods. Dinosaurs may have adapted by feeding on seeds, resilient packets of life that persisted through years of darkness. Crocodiles, able to survive long stretches without food, waited out the famine in rivers and swamps. It was not strength that guaranteed survival, but adaptability. The rulers of the Cretaceous, the colossal dinosaurs, the soaring pterosaurs, the great marine reptiles, were bound to niches, too specialized, too fragile. When the world shifted, they could not bend. The survivors remind us of the role of chance. If the asteroid had struck elsewhere, if the eruptions had been weaker, if climate had turned in another direction, the story of life might be unrecognizable. Dinosaurs could still roam the earth. Mammals might have remained small, hidden, insignificant. Humanity might never have emerged. Extinction is not only a story of death, it is a story of possibility, of worlds that might have been, and of futures forever unwritten. Reflection theories and speculations multiply because the truth, even when carved in stone, resists simplicity. The deadliest day in Earth's history was not merely an ending but a crossroads. Asteroid, volcano, atmosphere, ocean all played their roles, in ways still debated, still mysterious. What is certain is this: the Earth is fragile in the face of cosmic and planetary violence. Life endures, but never without cost. The extinction of the dinosaurs is not a closed chapter, but a lesson written into the fabric of the planet. Theories may shift, models may evolve, but the message remains. The universe is not benign. It does not conspire for or against life. It simply is. And life, fragile and resilient, must endure its storms. Drilling the crater beneath the calm waters of the Gulf of Mexico lies a scar still pulsing with secrets. Chicxulub, the buried crater, remains one of the most studied wounds in Earth's deep history. To touch it directly, scientists turned to drills, slender needles piercing through stone and time. In 2016, the International Ocean Discovery Program launched a mission to core into the heart of the structure. A platform anchored offshore lowered drills through hundreds of meters of water and limestone, sinking into rocks forged on the day the dinosaurs died. What emerged was not just stone, but testimony. Samples revealed shocked quartz fractured by pressures higher than any earthly volcano could muster. Glassy spherules spoke of molten seas of rock ejected into the air. Most striking was the presence of porous granite uplifted from deep in the crust, evidence of the rebound peak. A central mountain that rose and collapsed in minutes, frozen in the rock like a geological heartbeat. The sequence of destruction became clearer. First, the seafloor vaporized, then crust rebounded upward. Finally, oceans poured back in, entombing molten stone beneath layers of debris. Each centimeter of drill core was a frozen frame of catastrophe, a record that no eye had ever seen, but which science could reconstruct. The crater, once buried in silence, began to tell its story, simulating apocalypse drilling into Chicxulub. Recovered fragments of the past, computers became windows into its unfolding. With equations and supercomputers, scientists recreated the apocalypse. Three-dimensional impact simulations modeled the asteroid's descent, its strike into shallow seas, and the shockwaves rippling through rock and water. The images were haunting. A wall of fire and vapor taller than the Himalayas, continents trembling as if liquid, the sea itself boiling away. But the greater revelations came from climate modeling. Using data from the crater and chemical traces in rocks, scientists simulated the aftermath. Dust clouds spread across hemispheres. Sulfate aerosols, suspended in the stratosphere, dimmed the sun. Within weeks, surface temperatures plummeted. Some models suggest global averages fell by as much as 25 degrees Celsius in certain regions. Photosynthesis collapsed. The models revealed oceans cooling from the surface downward, stratifying and suffocating. Acid rain scoured landscapes, its reach global. Its persistence measured not in weeks, but in years. Supercomputers gave shape to what fossils only hinted. The catastrophe was not a single strike, but a chain reaction of planetary failures. What simulations revealed was not only the past, but a warning for the forces that ended the Cretaceous still exist, waiting in the void. New evidence in fossils while drills and simulations explored physics. The fossils whispered of survival and loss. In North Dakota's Hell Creek Formation, a site known as Tanis preserved a graveyard frozen in time. Fish entombed with glass spherules in their gills. Trees toppled and buried by inland waves, a snapshot of the hours after impact. These fossils bear not just the mark of death, but of sequence. The timeline of extinction compressed into stone. Microscopic fossils, too, reveal the recovery. Foraminifera, tiny marine organisms, vanished almost entirely at the boundary, yet their descendants reappeared within tens of thousands of years. This slow repopulation sketches a portrait of Earth healing in geological time. Even DNA has begun to play a role. Paleogenomics, though limited for such ancient events, is reconstructing survival strategies in lineages that endured. Genetic evidence hints that small body size, dietary flexibility, and rapid reproduction were keys to persistence in a world turned hostile. Each fossil, each genome, is a fragment of testimony. Together, they form a record of not only what perished, but what clung to life. They show how fragile ecosystems collapse, and how resilience emerges from the margins. Looking to the skies, the study of Chicxulub is not only an autopsy of the past, it is a rehearsal for the future. Asteroids still orbit the sun, silent wanderers that cross Earth's path. NASA estimates that more than 25,000 near-Earth objects larger than 140 meters exist, with thousands yet undiscovered. None currently threaten imminent impact. But the lesson of Chicxulub is clear. Vigilance is survival. In 2022, humanity tested its first planetary defense. The Double Asteroid Redirection Test, DART, hurled a spacecraft into Dimorphos, a small moonlet of the asteroid Didymos. The collision shifted its orbit, proving that an asteroid's path can be altered by human hands. For the first time, a species had reached into the cosmos and nudged fate. Observatories now scan the skies relentlessly. Projects like NASA's Near-Earth Object Surveyor and Europe's Fly Telescope seek to catalogue every potential threat. Computer models predict trajectories centuries ahead, calculating risks, planning contingencies. Yet Chicxulub remains the cautionary tale. A reminder that detection is not enough, that preparation is fragile, and that life on Earth is at the mercy of celestial chance. The crater beneath Yucatan whispers to every generation, the sky is not empty, and time is not infinite. Reflections of urgency, science drills the rocks, models the skies, and deciphers the fossils, not out of curiosity alone, but out of necessity. For Chicxulub is not only history, it is possibility. The dinosaurs never saw their executioner. Humanity has the gift of foresight, but foresight is nothing without action. Every core sample lifted from the crater, every simulation rendered by supercomputers, every telescope trained on the heavens is part of the same project. To learn enough to endure, to ensure that when the cosmos casts its dice again, Earth is not caught unprepared. The story of Chicxulub, once an echo of extinction, has become a guidebook for survival. It reminds us that fragility and resilience are two sides of the same coin, and that science is our only defense against silence from the skies. The fragility of dominance for over 150 million years. Dinosaurs ruled the Earth. They filled every corner of land, air, and sea. Titans of endurance, paragons of adaptation. To them, the world must have seemed eternal. Yet, in less than a single day, their age was silenced. This truth humbles the present. Humanity, in comparison, has held dominion for barely a heartbeat of geological time. Civilization, agriculture, language, cities, spans only the last 10,000 years. Even our earliest ancestors, the makers of stone tools, walked the earth for mere millions. Against the reign of dinosaurs, our story is a flicker of light, and still the illusion of permanence lingers. Towers rise, machines orbit the planet, knowledge maps the genome and the galaxy alike. Yet the fate of the dinosaurs whispers otherwise. No dominance is secure. No rule beyond the reach of chance. Earth, though ancient, is fragile. Its kingdoms are built on the shifting ground of fortune. The gift of catastrophe yet in destruction lay possibility. When the asteroid struck, it did not erase life itself, only its prevailing caste. In the void left behind, small creatures, mammals burrowing in the soil, shivering in the shadows, began to ascend. Without Chicxulub, the line of primates might never have flourished. The spark that led to language, art, and consciousness might never have ignited. Humanity itself is, in a sense, the child of extinction. The asteroid was both executioner and benefactor. It shattered one dynasty to allow another. The age of reptiles gave way to the age of mammals, not by gradual replacement, but by sudden vacancy. Life, opportunistic and restless, rushed to fill the silence. In this paradox lies a haunting lesson. Catastrophe is not only an end, it can be a gift, violent, merciless, but fertile. From death, creation. From silence, the seeds of new voices. The cosmic lottery, the universe, is vast beyond comprehension. In its immensity, Earth is but a speck. drifting through space like a solitary ember in a dark sea. And yet, on this fragile speck, life rose, endured, and questioned its own origin. But survival, history reveals, is not the product of certainty. It is a lottery. The asteroid that ended the Cretaceous was not aimed, it was not destined. It was chance, blind and impartial, striking one world out of billions. One day out of endless time. If its trajectory had shifted by hours, or even minutes, it might have missed. The dinosaurs could still dominate. Humanity might never have been imagined. The thin balance between existence and absence rests on scales far beyond human control. This is the cosmic lottery, a reminder that intelligence, culture, even the story of life itself, is not inevitable. It is provisional. It exists because chance allowed it. The dinosaurs remind us that nothing in the universe promises permanence. The same forces that once birthed us still wait beyond the horizon of stars. The scar beneath the earth today, the scar of Chicxulub, lies buried beneath the Yucatan Peninsula, hidden beneath jungles and seas. It is silent, yet eloquent, a wound pressed into the planet's crust, wider than cities, deeper than mountains. From orbit, satellites trace its circle, faint but undeniable. In cores of rock, its violence remains locked like a memory. Every fossil, every grain of iridium, every shocked crystal testifies to its reality. It is more than a crater. It is a monument to impermanence. It whispers of a day when the sky fell, when fire consumed countenance, when the rulers of the earth vanished without appeal, and it asks a question that has no comfortable answer. If an empire of giants could be erased in hours, what of us? Final reflection. The day to come, the story of Chicxulub, is not a tale of the past alone. It is a mirror, angled forward as much as backward. It reflects our own precarious place in the cosmos. One day ended an age. A single sunrise saw the world before the asteroid. The next saw its aftermath. For the dinosaurs, there was no warning, no preparation. For us, there is foresight. Telescopes watch the sky. Probes strike asteroids. Yet even with vigilance, certainty is impossible. The question lingers, heavy and unyielding. What day will end ours? Will it be written in fire from the heavens, or in silence of our own making? Will it come in centuries, or tomorrow's dawn? No one can say. But perhaps the deeper lesson of Chicxulub is not fear, but awareness. Awareness that life is rare, fragile, and finite. Awareness that survival is not a right, but a gift, one easily withdrawn. Awareness that in every day given, there is both impermanence and possibility. The dinosaurs leave behind no voices, only bones. Humanity still speaks, still dreams, still chooses. The scar beneath Yucatan reminds us of what was lost and of what is still possible to protect. For as long as the sky remains, the lottery continues.